Hi, everyone. My name is Braden McCullough, and this is
Priscilla Haro.
and it is a very exciting day here at the University of Miami. We are at the Engineering Senior Design Expo, and Priscilla will tell you a little bit about what that is.
So the Senior Design Expo is a series of teams of engineering students, and they've worked on for the past 2 semesters on their ideas to help bring them to life. So let's go check out what they have to offer because we have a lot to learn. Let's go.
All right, so here we are at our first table. We have a group of industrial engineering students. Could you go ahead and introduce yourself?
Yes. Hi, my name is Trevor. This is Daniel Delgado, and then this is Roshan Russell.
And can you go ahead and tell us a little bit about your project?
Awesome. So for our project, we work specifically with the company Costa Farms. Costa Farms is the largest plant grower in the world, practically, and specifically we focus on the Grillings facility. At the Grillings facility, they operate working with bonsai and bamboo, and Daniel can talk about some of the specifics going forward.
Yeah, so what we did is we redesigned and relocated their processing area, which is where they add cosmetic enhancements to some of their products, like the bonsai that we have behind me. And Roshan will talk a little bit about what we saved them.
So what made our project unique compared to others was that we actually not only designed the new layout, but we were also able to actually implement it and see it into its entirety. As a result, we were able to save $100,000, which was about a 25% reduction in overall cost. And we saw an increase in efficiency for 74% for bonsai and 25% for bamboo.
Awesome, great. Thank you so much. Sounds like a great project. It's great to hear how you could actually implement this. And Priscilla will go ahead and take us to the next table.
All right, we're here with our next team. So can I have you guys introduce yourself?
Yeah, so hello, my name is Andrea, and we're here with Caution. We developed a semi-automated catheter system that connects to an existing catheter system and is able to screen for catheter-associated UTIs.
That's amazing, especially for people who have that same issue. And can I know what was the hardest part of your project today?
I would say the hardest part is getting every single part working. We are a very multidisciplinary team. We have very complex solutions. So we made everything from scratch, ranging from our chemical solution that we are using for potential infectious disease. And we're also doing our mechanical prototype. We have our own user interface. We have our own communication system. So having everything come together and having it able to be demoed right here in front of you guys was our top priority. And getting everything to work together was probably the most challenging, but rewarding thing out of all of it.
Well, I can definitely tell you guys worked very hard. Everything's put very well together. And now we're going to move on to our next team with Braden.
All right, and here we are with our next group. Could you go ahead and introduce yourself?
Yeah, my name is Marcus Morales. I'm a computer engineering student.
And could you go ahead and introduce yourself?
Zubair Chaudhary, computer engineering, software option.
Hannah Pignano, electrical engineering.
Awesome. And could you just tell us a little bit about your project?
For sure. So a large problem with university course enrollment is that you don't know how fast a course is going to fill up, right? You usually have your enrollment date spread out throughout the week. And if you have less credits, you're going to have an enrollment date later on, like Thursday or Friday, right? So if a course fills up on Tuesday, you're out of luck. And you can't really plan for those things. So what our website does is we went ahead and we scraped all of the Canelink course enrollment data. And now our website can show you, you can just look up one of the courses and you can see how fast the course fills up so that you know ahead of time and you can plan your course schedule a bit better.
Awesome, great. And can you just quickly tell us what your favorite part about this project was?
Definitely building the front end was very interesting and fun, something I haven't done before.
Awesome, great. Thank you so much. Great, good job, guys.
Thank you.
And then we'll have Priscilla show us our next group.
Hello, we are here with our next team. Can I have you guys introduce yourself?
I'm Nate Joseph.
Hi, I'm Yusuf Al-Wardani.
I'm Angela Mazares.
Wonderful. And can you guys tell me a little bit about your project today?
Yeah, so our project, VR Connect, we use MetaQuest headsets to interact with Internet of Things devices. So that includes like smart lights, smart speakers, and cars. Those are demos, but you really use that with anything. It's here to enable developers to be able to interact with real life things while in the virtual world. Yeah.
Yep. And as technology continues to develop, we do see these start to rise in trend. So what kind of inspired you about what's already on the market to design this?
Well, this kind of thing just doesn't really ever happen. You know, a lot of these applications like this, they're very few and far in between just because of how hard it is for developers to really incorporate this kind of technology. So for us, like, we thought it'd be a great idea to bridge that gap and allow people to really access like the real power of like these headsets that you can really tap into.
Yes, I completely agree. Well, I can tell you guys did your research. That was very interesting, and thank you for your time. Now we're going to move on to our next group with Braden.
All right, and now we have our first innovation, technology, and design group. If you could just go ahead and introduce yourself.
I'm Anna Munson.
I'm Catherine Kwong.
And can you just tell me a little bit about your project?
Right. Our project is called Local Lens, and the basis of our project is basically that we notice that when people leave the country, and they travel abroad, that they often prepare for, where they're going to stay, what they're going to do, what airline they're going to take. But what they do not prepare for are these day-to-day cultural norms that are specific to the country that they're traveling to, right? So, and these things can really cause cultural shock and can honestly ruin your trip. Like, did you know that in Jamaica, it's considered illegal to wear camouflage if you're not in the military? Or, like in Russia, it's considered rude to smile at a stranger.
Did not know that.
Yeah.
Our product is an AI-powered app, and it generates practical insights on these unwritten rules. And they're based off of real traveler stories. And the information is generated based on also personalization. So based on your demographics, if you're what your gender is, your nationality, so what country you're coming from, if you have a disability, things like that. And in addition to generating these insights, the travelers can also save the insights to access before, during, or after their trips, and they can contribute their own experiences so that it goes into crowdsourced information, so that when we have enough, it will generate insights based on that crowdsourced information.
All right, awesome. Great project. Thank you so much. All right, and here we'll head to the next one.
All right, we're here with an industrial engineering table, and as you can see, it's very visual, very colorful, and I'm excited to learn about it. So, what's your name?
My name is Jessica Mendez.
Wonderful. And can you tell me a little bit about your project?
Of course. So my project is identifying PTSD through sleep patterns. So as you see, there's a PSG polysomnogram sleep test. And through this, we're able to accurately and reliably identify PTSD. So the current diagnosis right now for PTSD is only through subjective reporting. So this, of course, can have some bias, a stigma, like sometimes intentional misrepresentation. So the objective of this project is to provide an algorithm to actually reliably being able to identify PTSD.
Definitely. And since it has in the context of biomedical, if you were to team up with other biomedical engineers, what do you think you guys would research next with this project?
So that's a really good question. This is something that can be very further analyzed and developed. This is like probably the first time that somebody does this type of diagnosis of PTSD. So definitely something that could maybe through another methodology or algorithm being able to identify it with a higher accuracy, I guess.
Definitely, I definitely agree. And with these kind of projects, they help with disparities and different issues. And now we get to go on to the next group.
All right, then here we have our next group. Looks like we have some mechanical engineering students. So if we could just have you guys introduce yourself real quick.
All right, so I'm Anthony Crespo.
I'm Reese Semantic.
Mary Goncharenko.
And can you just tell us a little bit about your project?
So pretty much we designed a dental implant with Amloy ZR01, which is a hypoallergenic material. It's superior to titanium and gold for hypoallergenic properties. And we pretty much just designed and we printed it out of titanium.
Awesome. And what would you say the most challenging part about this project was for you?
Probably getting the new material to print, because we had no idea what the parameters were for it. So we basically had to start from scratch.
All right, great. Sounds awesome. Thank you so much.
All right, thank you.
Yep. All right, and then Priscilla will take us to our next group.
All right, and here we are with our next group. If you guys don't mind introducing yourself.
Yeah, so my name is Toby, and my group members are Christopher Lawrence and then Yuri Palacios over there. Our project is known as the Portable Hinge Wing Auto-Stabilized Sensing and Testing Drone, also known as FAST. It was designed around methane sensing. It was designed around a methane sensing mission. A big problem with methane sensors today is that they're stationary. They're only based on time-dependent data. We wanted to apply that to a drone to allow us to get some position-based data, which also allows us to model the vertical dispersion of methane plumes. Our mission design is based around a transition mechanism, which takes us from vertical takeoff and landing, which folds to fit inside a duffel bag. Our drone's only 17.5 pounds, so it could be carried and deployed by really anybody. Our flight computer maintains stability through our transition, and then our fixed wing configuration allows us to maximize our range and endurance to achieve as much testing as possible for every given mission.
Wow, that sounds very amazing. And I'm wondering, when you guys are designing this, what kind of testing do you do? If not prototypes, if not different testing with different softwares, how do you really analyze your results?
A lot of it has to do with SolidWorks stress analysis. We did experimental thrust testing. We had a thrust mount. We took a bunch of different propellers. We would model the forces, and we would compare those to the angle of twist of our wings as we went through transition, which would allow us to maintain our stability. Our next steps would definitely include a fatigue analysis due to the vibrations of our system. A lot of aerospace systems are plagued by those types of issues. And yeah, it really had a lot to do with stabilization, modeling our trajectory, and just making sure that all your components are safe before, given, and after.
Well, this was a very innovative project. You guys should be proud of yourself. And now we'll be moving on to our next group with Braden.
All right. I'm sorry, guys. I'm going to have to interrupt real quick. We have to do the live broadcast. Could you just tell us who you are real quick?
My name's Jenna. I'm a software engineer.
I'm Banna, and I'm a computer engineer.
I'm Nick, and I'm an electrical engineering major.
Amazing. And can you just tell us a little bit about your project?
So we created FastPass. They're sensors that we placed around the library. We take into account LiDAR, so movement, microphones, so noise, and then Wi-Fi sniffing, so all the devices that are taking up Wi-Fi bandwidth. And we tell users exactly how busy the library is. So right now during finals, a lot of kids are driving across town just to sit at the library and realize they don't have a seat. So you can go onto our website, figure out if you're going to have space. And if you don't, we have a massive database with all the classrooms and study spaces. So if you need to find an alternative, you can do so easily.
Awesome. That's so great to hear how you guys are solving a problem that a lot of students here at the university face. So I applaud you on that. And it's also great to hear how 3 different engineering majors came together to make this happen. So thank you so much. And Priscilla will take us to the next group.
So we're here welcoming our next group. If you guys don't mind introducing yourselves. I'm Abby Pinkerton.
I'm Ashley Carr.
I'm Sophia Franciosa.
I'm Natalie Zaleski.
Okay, and tell me about your project today.
Yes, so we are BlazeBlade, and we have created a device that a burn surgeon at the Miller School has said has the potential to modernize the surgical technique that is not advanced in 50 years, and that technique is debridement. Debridement is very important for third-degree burn patients. It is the process of removing dead tissue from these burns, and the current tools being used are a wet blade. So our device is an oscillating blade that increases efficiency of this cutting. We did this with a linear actuator that produces the oscillations and a potentiometer that affects the speed of these oscillations. We tested this on artificial skin, proving that there's a 40% decrease in time of cutting with our device versus just a normal cut. We also tested this on a cadaver, which showed successful cutting on places such as the calves and fingers. And with a higher torque motor, we can also work on areas such as the thigh.
Sounds amazing, and I'm so glad that you guys were able to partner up with the Miller School. This definitely goes in hand with optimizing new solutions. So what inspired you guys to reach out to the Miller School to just find out if this is really applicable?
I think the professors had kind of encouraged us to use our abilities as students here, use our resources, and Dr. Schulman was immediately extremely responsive and just super excited to assist us where we could. So he really helped make this happen for us, including our testing on a cadaver and things like that.
Well, this was very amazing. They do say engineers transform lives, and you guys definitely can. Thank you. We'll be passing it on to Braden now.
And we're here with our next group. If you could just go ahead and introduce yourselves.
I'm Aiden McKenzie.
I'm Gianni Hernandez.
My name is Ashlyn Mock.
And could you just tell us a little bit about your project?
Yeah. So we created a solar-powered scooter charging station for college campuses worldwide, a place for them to keep their scooters secure, covered, and charged all day while they're in class.
Great. And what inspired this project?
So if you walk around campus at all, you could see there's scooters everywhere. We have a whole slideshow of just scooters thrown all over campus. And there's even signs saying, don't bring your scooter indoors. And so that's how we came up with the problem. And we decided we needed somewhere specific for scooters to be parked on campus. And that's how we came up with this idea. We thought parking and charging in one. We have a 24-foot diameter solar panel array on top that powers the scooters and also sends energy to the grid.
Awesome. And can you just tell us real quick what your favorite part about the project was?
I think identifying the problem, seeing that there was this issue going on that no one was really talking about was really exciting. And we're just really happy to be one of the first going into this market.
Awesome. Great. Thank you so much. This project's incredible. And I look forward to seeing what you guys do next. And Priscilla will be over here with our next group.
So we are here with our next group. Tell me about yourself and your name and your project.
So my name is Nicolas Gallardo. My project is called MindWatch, and it's a mental health screening app to tackle the delay between people showing their first symptoms and actually seeking help. This delay can be between 1 to 30 years. It really depends on the individual, and this creates a lot of pain points for the user and worsens the outcomes of the treatment. So this application actually uses your mental health and smartwatch data, so heart rate, sleep, activity, runs it through a trained machine learning algorithm, and then detects the probability that you have or not a mental health disorder.
And considering that we have devices on us all day, whether that be cell phones, Apple Watches, would you ever consider actually launching this to be available to the public?
Yes, I consider launching it. It would be something for the longer term, because after doing this, I realized to implement it across all devices, it would take a lot of time work. But I definitely think the idea would be great, and especially would help a lot of people, because there's an epidemic when it comes to mental health right now. So I really want to get this to actually help people.
Definitely. Thank you so much for your time. And we'll be moving on to our next group with Braden.
All right. And here we are with a group of industrial engineering students. Could you just real quick go ahead and introduce yourselves?
Hi, I'm Isa. I'm the team leader.
I'm Ben Hanna.
I'm Gavin Kern.
And can you tell us a little bit about your project?
So our goal here was to optimize the student experience by trying to make the registration process better. So we collected data on what the students feel, what the advisors feel about the registration process, and and we had a lot of different recommendations. For it, and two of our main recommendations. One was Cane Chat, which is AI trained to respond to students' inquiries. And they have like an FAQ website right now on the University of Miami website. But we, based on our data and our interviews, we saw that a lot of the students don't use it. So we recommended having an implemented AI into the university website or even Canelink. So it responds to like general prompts. And also we recommended automated responses to emails using Zapier. So yeah, these are two of our main ideas, but also we had like a smaller ones that I don't need to get into details.
And just real quick, can you tell us what the main challenge was while doing this project?
Well, the main challenge is that the registration process right now is very inconsistent. So they don't have a right way of doing things. And I think that the process should be standardized. And the process should be standardized because most of it, they don't follow a process, which sometimes it works for a student, sometimes it doesn't. So we couldn't do a right process map for it. So it was very confusing for us. And also they have a lot of small problems that should be addressed. So it was hard to address all of them.
Awesome. Great. Thank you so much for telling us about your project. It sounds amazing, and I wish you all luck. Yep. And we'll head over to our next group.
All right, we're here with our next group. And if I could have you guys introduce yourself and tell me a little bit about your project.
I'm Aiden.
I'm Alyssa.
I'm Ben. And we're SimuStride, the early intervention that amputees deserve.
So we're giving kind of a segue, a rehabilitation device that amputees can use before they get their prosthetic. A big problem is that a lot of amputees face phantom limb pain, which is pain in the limb that's no longer there. And then you can imagine when it takes months to get your prosthetic, you're losing your key motor skills that you once relied on to do your favorite things, whether it's walk, sit, run, whatever it may be. So our device kind of helps retain those motor skills and also fight phantom limb pain by allowing the users to control a virtual prosthesis until they receive their prosthetic.
Definitely. And what inspired you guys to do this kind of, I know a lot of victims suffer from this, so what inspired you guys to start this project?
Yeah, I think that's a great question. We're all biomedical engineers, but we all have different backgrounds. I have a mechanical background, Aiden has an electrical background, and Ben is on the pre-medical track. We've always been drawn to rehabilitation and specifically with amputees. So kind of just merging our all three passions into one project has been such a fun experience.
Well, I definitely think that's what engineering's about, just meshing together the different skill sets that you guys have. You guys did an amazing job. Very impressive. Thank you. We'll turn it over to Braden.
Great. And I'm sorry, guys, I'm going to have to interrupt. We have the live broadcast going. Looks like we have a group of mechanical engineering students. If you could just go ahead and introduce yourselves real quick.
I'm Garrett Trailer. Justin Jaro. Hi, I'm Nick Caboni.
And could you just introduce yourself real quick?
Hello, I'm Alex Espinoza.
Perfect. And can you just tell me a little bit about your project?
So EPC Power is a company in California. They develop very large-scale power inverters. They have a new model currently in production, and essentially our goal was to develop an air-to-air liquid-free cooling system for that new power inverter. Essentially, it uses independent cross-flow and a plain fin heat exchanger to cool the heat load. And what we have here is just a test apparatus that mimics that power inverter, and we have a hot plate as the heat load.
Great. And can you just tell me real quick what the favorite part about this project was?
For me, the favorite part was definitely the physical construction and watching a lot of our, calculations from physics classes come to life and come to fruition and have like a physical model.
Awesome. Great. And would you say that there is any challenging aspects about this project?
Yeah, definitely the calculations. This is pretty, intricate and niche calculations with heat exchangers, but also working with Arduinos can be a little tricky. They have nuances to them. Yeah.
Collecting the data was definitely one of the hardest parts. Just get the Arduino together with the thermocouples and everything. So, yeah.
All right, perfect. Thank you so much.
All
Your
right,
project sounds great, and I wish you all luck.
Thank you. Appreciate it.
All right, and we'll head to our next group.
All right, and we're turning it over to our next group that's actually industrial engineers as well. Can I get you guys to introduce yourself?
I'm Stelios Lianu.
And I'm Fadi Bibawi.
Perfect. And tell me about your project today.
So we're team 31. We were working on course scheduling optimization for the College of Engineering. So the current process is very manual, very inefficient. Each department has kind of their own way of scheduling classes, their own Excel sheets. So we want to have a centralized process that kind of eliminates the back and forth between the program manager and each department. And our solution has two phases. The first phase of our solution is some specific policy change that we want to implement. The first policy change is a standardized Excel sheet that each department is going to use to input it into the web-based solution that we have. The second part of our solution is going to be an interest form that students are going to submit a year before their actual classes start, so we can forecast demand for future classes. And then the final phase of the policy changes is we want to introduce a rule where when the deadline passes and classes haven't been scheduled, that class has to go and move after 5 p.m. And so Fadi's going to take it from here and introduce the software.
So for the software, it's actually a centralized system for the College of Engineering. It will be across all departments. They have their own portal they can use for uploading classes, changing the class schedule, or even looking for any overlaps between classes or conflicts for a specific professor, or also any missing classes that should be scheduled, but it's not scheduled yet. So it's a centralized system. It actually planning to save the time for this process from 9 months and more to actually just 1 month. We can have a perfect schedule. We can check for any problem with it without doing the manual process of a pen and a paper.
Definitely. And like a lot of students, we've all sometimes struggled with scheduling our classes. So this is very applicable. And I'm very happy for you guys. Great team. We'll move on to Braden next.
All right, and here we are with another ITD group. Could you just introduce yourself real quick?
My name is Anthony Santoro, and this here is Muscle Band. So basically, for a quick rundown, the user would put on this EMG-based armband. It's called the MyWear Wireless Shield. And they would record 3 bicep repetitions. And then from there, the system, the code, will take those 3 repetitions, it will average it, and they would take the root mean square, which means basically it'll cancel out all the excess noise, making sure the data is as valid as possible. And then from there, it would then display the data onto the web app, and then the user would then do it for the other side. And then from there, it'll display the percentage muscle imbalance that the user has in both of their biceps. And then from there, the user can click on it and then see like what that percentage exactly means. If the percent is under 10, then they're considered safe. They don't really have to work on anything. It's considered normal, perfectly fine. If it's between 10 and 15, they're like, okay, you should work on a few other things. And if it's more than that, usually it's like kind of concerning. It's like you should reach out some physical therapy resources. The user can also access their previous trials to show whether or not they're improving or whether or not they should get better. And yeah, that's about the rundown.
Awesome, great, thank you. With ITD being such a new degree, it's awesome to see how well you all are doing. So thank you, and good luck with all your future endeavors.
Thank you so much.
And we'll head over to the next group with Priscilla.
All right, we're here with our next group. And can you please introduce yourself and tell me about your project?
Yes, hello, my name is Andrew Lynchner. I'm a student in Innovation Technology Design here at University of Miami, and my project is called StatLane. It's a dashboard that helps drivers understand their driving habits better, and it helps them understand how much money they're saving or losing based on how efficiently or inefficiently they're driving.
That's a very interesting idea. So how did you go about actually doing your project?
Yeah, so what I did is I got a vehicle, of course, and I got these OBD2 monitors, which is onboard diagnostics, and plugged it into the car. This tracks everything you'd want to know about your vehicle, like speed, RPM, harsh braking, tons of great statistics. It compiles all of that into CSV files. I ported those CSV files into Dropbox Cloud, so every time I drove, it would automatically port those files into my Dropbox. And then using a web-based React dashboard and parsing all those CSVs, I use Papa Parse. So I'd pull it directly from the Dropbox Cloud, parse all the data, and then port it into the web-based, the React web platform. So you can see all your insights in a really easy to understand UI.
That's very interesting. That's definitely a feature a lot of companies are going to want to pitch you out for. We'll be moving on to our next team with Braden.
Hey guys, sorry to interrupt. Could you just real quick introduce yourselves?
So my name is Ahmed Zahar. I'm an electrical engineering student.
My name is Abdulaziz Salman. I'm an electrical engineering.
Awesome. And can you just tell us a little bit about your project?
So basically, we came up with an idea like to help emergency vehicles pass through and easier, especially here in Miami. People don't usually have the culture of moving away for emergency vehicles. So by our project, we made a device that can be attached into emergency vehicles, and with a touch of a button, he can change the traffic light for himself to pass easier and to move the traffic just for him to pass. And this can be an example. Let's say this is the emergency vehicle itself. With the touch of a button, all traffic lights become red and his lane becomes green just for cars to pass through and for him to get through. We made it because the 1 second can differ in emergency situations. And we believe this can be a huge thing, in case of emergency situations.
Great. I love the real world application here. It seems like a great project. And I want to say thank you for telling us a little bit about it.
Hello and welcome to our next group. Can I have you ladies introduce yourself?
I'm Kira.
I'm Sam. I'm Callie.
I'm Gabby.
And can you tell me about your project today?
So we created an at-home Epilepsy maneuver device that assists patients who have benign paroxysmal positional vertigo with the Epilepsy maneuver. Using a gyroscope and accelerometer on the head, it will walk patients through angle movements of their head and then buzz at these correct movements. The Epilepsy maneuver is on the top there. You can see it's a series of head movements.
And I see that you guys have a final prototype here. Who are you guys aiming to help with this project?
We're really aiming to help patients that have a limited access to healthcare. It can be really hard to get in to see a doctor to do this maneuver for them. PTs can be really expensive or booked out really far. And then there's a really high recurrence rate with patients that get BBVV. They get it another time and a time after that. So this makes it a lot more accessible and low cost for them to be able to do this at home more than once and really make sure they're doing it correctly and safely.
Definitely. This is very innovative and will definitely help a lot of patients in the future. Thank you, ladies. And we'll turn it over to Brady next for our next group.
All right. I am here with our next group. Could you just real quick go ahead and introduce yourselves?
Hi, I'm Anna Scari.
How's it going? I'm Garrett Miller.
I'm Spencer Pearson.
I'm Kayla Thompson.
Madison Morneau.
Morgan Lutz.
Awesome. And just real quickly, could you just describe your project real quick?
Absolutely. So our project mainly focused on green stormwater infrastructure along certain sections of the Miami River. So last semester we did some investigation on the water quality of the Miami River, which is the main water body which runs through downtown Miami and opens up into the Biscayne Bay. We found there was super high nutrient and bacterial levels entering the river, mainly from stormwater runoff. So what we did this past semester was design 3 main types of engineering devices: exfiltration trenches, bioretention cells, and permeable pavement. And what they do is essentially eliminate that pollution from entering the river. In some cases here, we were able to fully eliminate the pollution entering the river in specific areas. So it's all about keeping a cleaner Miami River and a cleaner Biscayne Bay.
Great. Sounds like an amazing project. I really appreciate how you guys are tackling some environmental issues, and a great job. Thank you. And we'll head over to Priscilla with our next group.
Hello, we are here with our next group today. So we are here with our group who actually studied the farmers market that takes place every Wednesday at the University of Miami. So tell me your name.
My name is Noah. Alejandro.
And tell me about your project today.
So our project is Breathe. That is low-cost air quality monitor. So air quality is a huge issue. Air pollution in general drops the global life expectancy by 2.2 years. That's more than smoking, drugs and alcohol, car accidents. And so, policy and infrastructure change are the big things that are really going to fix the air quality crisis. And the issue with that is that air quality is a very hyper-local issue. The difference of one block could mean that one family is really close to a busy intersection during rush hour, and they have much worse air quality than people on the other side of the block where their air quality is completely fine. And so, if you have weather stations have really high quality, very expensive air quality monitors, but if they're 5 miles apart and one of them's reading that they have really bad air quality and the other one's saying it's fine, how do you know who's affected in between? And so our project is to create a low-cost air quality sensor so that you can kind of create a gradient between those larger quality, like higher cost air quality sensors, and determine who's being affected in between.
So what inspired you guys to actually go and look into the farmers market, particularly when it comes to air quality?
Well, I was telling another gentleman, I think you overheard, we weren't looking for any information saying that the farmers market is bad air quality or anything like that, but we tested them in an indoor environment with known calibration gas, and we wanted to make sure that they had some sort of response in an outdoor environment. So we put it right next to a generator that is a known emitter of carbon monoxide. We put it right next to the grills that's a known emitter of particulate matter, and we just wanted to make sure that there was some sort of response from those sources.
Well, this definitely helps out a lot of vendors and small businesses that come to the school every Wednesday. So it was very thoughtful of you guys and definitely innovative. Thank you so much. And we'll be turning over to our next group with Brayden.
All right, and we are with our next group. Sorry, I have to interrupt real quick. We're with the live broadcast. Real quick, could you just go ahead and introduce yourselves?
My name is Ricky Reina.
I'm Joshua Torres.
And I'm Allie McGuire.
Great, and can you tell us a little bit about your project?
Yeah, so basically we just designed a shirt that football players can put under their existing football padding. It is non-Newtonian-based fluid material, so the material is soft when they're playing, and once they're hit on whatever point of impact, it turns hard, and it allows their upper body to be protected by it.
Great, and could you tell us what the most challenging part about your project was?
I think that was finding the best materials to do this job. With football players, the range of motion is essential to play their sports. We needed to find something that did a great job distributing and absorbing the force without limiting the range of motion.
Awesome, great project, guys. I like to see it.
Welcome to our next group. And can I get everybody's name?
Yeah, I'm Gabriel de Hostos.
I'm Catalina Munoz. Chelsea Reynolds.
And tell me about your project today.
So we are Guppy Guard. We are a way to address the over 4,000 deaths that there are annually in the U.S. from drowning in children ages 1 to 4. There are no existing solutions that actively prevent drowning once it's begun. You have things like pool fences, but those things don't intervene once it's begun tragically. So our solution is an automatic and wearable device specifically for a target population of ages 4 to 8, 1 to 4, smaller children and pets. We wanted to make sure that we can generate enough buoyancy to keep those victims afloat and have moisture-based deployment to not introduce any electricity to that situation. In testing our product, we wanted to make sure that we could deploy and have the air release for 30 seconds, that we can inflate within 3 seconds, and that we can maintain the average weight of a child in that demographic. And we were able to achieve all those things. And most promisingly, our current setup inflates to about 9 liters of air. We would only need about 0.81 liters of air to keep a small child afloat, meaning we can downsize tenfold. So that's where we look to improve.
Your project is very applicable, and I'm sure can help many families prevent such a tragedy from occurring. And I really enjoyed your project. Thank you, and we'll be turning over next to Braden's group.
All right, I'm sorry to interrupt real quick. We're going to do the live broadcast just real fast. Hi, guys. Could you go ahead and introduce yourselves?
Yes, hi, my name is Abdullah Latabi, and this is my partner, Yusuf Asayir.
All right, and can you tell me a little bit about your project?
Yeah, so our project is simple. It's a predictive maintenance system. What it basically means is it can predict like any failure that happens into engines or like machines in a factory, and it helps you like not get a maintenance check. It can check everything by itself with a simple website to use on.
Awesome. Seems like a great project. Thank you for your time, guys. We'll head over to our next project with Priscilla.
Hello, and welcome to our next group. We're here with our next presentee. Can I have your name?
Hunter Todd.
And tell me about your project today.
Yeah, so my project is called UScholar, and as an undergraduate student, it was very difficult for me to find those research opportunities on campus. So that's where I created UScholar. It allows students to upload their projects and research, and also find research opportunities on campus.
Perfect. And what inspired you to do this project today?
So it was actually my own experience with trying to find those research opportunities. I tried to talk to a professor, and I was referred to another professor, who then referred me to another professor, who referred me to yet another professor. And so I was trying to bridge that gap where students can all find that same research opportunities on the same website.
Perfect. This is going to help many students in the future, especially our new incoming students who are looking for research opportunities. Thank you. We'll be turning it over to our next group with Braden.
Here we are with our next group. Could you just real quick go ahead and introduce yourselves?
Okay, so I'm Hamza and this is Turkey and that's Dima.
Great. And can you tell us a little bit about your project?
Okay, so basically we're working with a company called Global Displays and they had issues with the labor cost tracking when it comes to each individual project. So what we suggested to them is these weekly timesheets. These timesheets where every day each employee would be able to log down which project he worked on and how many hours he worked on. Through this, we can put it all into Excel, and from the Excel sheet, we can get this report out, which we are able to compare the estimate of how much they estimated the project to cost, and how much they actually spent on it when it comes to labor.
Awesome, great. And what was your favorite part about completing this project?
What I really liked is it gave us a insight of how it will be like working in the future with a real company and seeing how like the financials work and going on site and seeing how the whole process works of the whole company.
Awesome. Thank you so much for telling us about your project, and great job, guys. All right, and we'll head over to our next group.
We're here with our next group. Can I get a name?
Yeah, I'm Quinn McGowan.
Perfect. And tell me about your project today.
Yeah, so the project that I'm working on is attempting to tackle the crisis of drink spiking. So right now, substances like GHB, Rohypnol, ketamine are being used in bars, clubs, concerts, that sort of thing to spike drinks. And the problem that I encountered is all the products are consumer based. So you have to buy a testing kit for your wrist. You have to buy a cover for your drink or whatever it might be. And so what I attempted to do with my project is to shift that responsibility of safety onto the venue itself by replacing the cups that they currently use with kind of safety tamper-proof cups to shift that security into a built-in standard.
Yep, and I definitely think that would bring a lot of attraction to the restaurant itself.
I was going to say, it removes liability too, because at present, if somebody gets spiked in their venue, they have to call the cops, they have to call the fire department. So it removes the liability in a sense as well. Yeah.
Well, this is a very amazing project that I'm sure a lot of college students could use for their own safety. I appreciate your time. I'm going to move on to the next project with Braden.
Right, we are here with our next group. This looks very interesting. Could you just go ahead and introduce yourself?
I'm Amani Hendricks.
I'm Grace Wilson.
Great. Introduce yourself for us, please.
My name is Lucas Lopez.
And can you tell us a little bit about your project?
So our project is a solution to eye exenteration. So eye exenteration patients typically have their entire eye and surrounding tissue and sometimes bone removed. So they're left with a pretty big cavity in their face. And their solutions as of right now are the static eye patches and static fake eyes. So what we decided to create was a dynamic eyeball that tracks the healthy pupil using an IR camera and some set glasses. So when their eye moves, the other dynamic eye will move seamlessly with it, blinking as well. So it's an aesthetic project to help patients feel whole again, make them be able to live more of a normal life.
Great. I really like this project. It looks like you did a great job, and thank you so much for your time. Thank you. All right, and we'll head to our next group.
Welcome to our next group. We have industrial engineers here. And can I get your name?
Hi, Bruno Ribesi, Ariana Sequeiros, and Enrique Alonso.
And can you tell me about your group today and your project?
So we are Team 55. We work with Broadband International. They make telecommunication amplifiers out of Medley, Florida. What we did was pretty simple. The first recommendation was that we implemented WISES, which was a tracking system for all these unique components. In their factory, they have around 13,000 of these, and they occasionally got lost. Our second one was that we had finance check if these components were available before sending a production order to the floor. And our third system was pretty simple, was an MRP system. This would check if your stockouts were low, you would just order them on its own. And with these three implementations, we saved Broadband International $2.7 million a year.
Thank you so much. I love that you guys incorporated a little bit of finance into your project. That is what industrial engineers do. We try to optimize and see the most efficient way. Thank you for your time today, and we'll be turning it over to Braden.
We are with our next group. I'm sorry, I'm going to have to interrupt real quick. We're with the live broadcast. So if I could just get your names real quick.
Hi, I'm Samantha Spica.
Hi, I'm Aiden Puskis. Hi, I'm Tristan Loftus.
And could you just give us a short description of what your project's all about?
Of course. So as most people know, the current system on campus for bikes is you have to register if you impede, get a lock, keep track of a key, and it's a very complicated process, especially if you damage or lose it. So what we created is electronic bike lock that can be used with cane cards and RFID reader. So pretty much this is our electronic bike lock. It's most of our prototype, but these would be on the bike racks on campus. So pretty much the whole point would be that you'd be able to go up, lock your bike, just use your cane card, not have to carry around all the stuff that UMPD requires you to. We also have an app where you can see where the bike locks are on campus and whether or not it's in use or not. So yeah, it's pretty much just to replace that system. It's also solar powered to be more renewable as well.
Awesome. Sounds great. I love how this really solves a problem that a lot of us students here face on campus. So thank you so much for your time. All right. And here we are going to head to our second half of the broadcast, where we are going to head across the way. So far, the projects have all been great. There's a great group of seniors here, and needless to say, I am very happy
Hello,
with
we are
the
here
project
with
so
our
far.
next group today. All right, and can you guys introduce yourself?
My name is Chaya Shah.
My name is Praveed Magash.
And tell me about your project today. It looks very interesting.
Thank you. So this is WAVE, the Wireless Aquatic Video Explorer. So we want to tackle this challenge in the autonomous underwater vehicle industry, where to communicate underwater, you can't get live GPS, you cannot communicate wirelessly. So we have a buoy system at the top here that you can communicate wirelessly to, and it's live GPS. So our buoy system communicates through a tether to our drone. And this is applications for exploration, search and rescue, because you have this long tether destroying marine environments, and you can store in the water if you have anybody drowning to rescue them. Our main application we're thinking of is if someone falls off a cruise ship, 6% of the time you're not finding them. So with this in the water, you can easily rescue them.
Very amazing. And tell me about how long you guys took on your prototype. Like, who did you guys work with?
Yeah, so this took about a year. We worked with Cedric Guigan at the Rasmus School. Our faculty advisor is Dr. Dano. And we got help from a lot of people from the Blue Ridge Waters Company, where these motors are from, to get industry standard motors.
It's very impressive, and I can tell you guys had a lot of dedication into this project. Thank you so much for your time. And we're going to turn it over to our next group.
And here we are with another group. Hi, could you introduce yourself?
Hi, my name is Rachel Tomasetti.
And can you tell us a little bit about your project?
Of course. I am building Key, a personalized health toolkit designed for women to help them to understand their bodies and ultimately understand themselves. Women's hormonal cycles are affecting how they feel on a monthly basis, influencing, their brain chemistry, how they're thinking, feeling, and acting. So it's really creating a bridge between the mind and the body and helping the user to understand how what's happening internally that they might not be aware of impacting their external behaviors and helping them to align with their cycles and build self-awareness.
Awesome. I love this project. And just real fast, what was your favorite part about doing this project?
I would definitely say it would be the clarity it brought me and being able to articulate my vision and really understand what it is that I was trying and am trying to build. Yeah.
Great. Thank you so much. All right. And we'll head over to our next group with Priscilla.
All right, we're here with our next group. If you guys could just give me your names.
Darren. Laura.
My name's Omar.
And tell me about your project today. I see that it's very visual.
All right, our project is a feeding device designed for infants with cleft palate. Cleft palate is basically an underdevelopment of the roof of the mouth, so they cannot generate intraoral pressure, making breastfeeding almost impossible. We wanted to bring breastfeeding back and maintain that skin-to-skin connection between the mother and the infant, which helps with their bonding and helps the symptoms of postpartum depression.
Very true. Wonderful. I really like the application of this project, and it could definitely help many people in the future. We're going to go over to our next group now with Braden.
All right, here we are with our next group. Real quick, could you go ahead and introduce yourself and your group?
So my name is Jack Beddix. I am the project manager of the team, and we are Invicta Inc.
Great. And can you tell us a little bit about your project?
So we were tasked with redesigning this building in Omaha, Nebraska as part of a competition. And so me and my group members redesigned all the systems within the building as we are civil and architectural engineers. So I worked on the civil. Ben and Kelsey worked on the MEP systems, Grace on the structural, and Ella also helped me on the civil. So, yeah.
While completing this project, did you face any challenges as a group?
So I would say we worked very well together in that sense, but it was our first time actually attacking a project like this. Like a redesign is not so easy and simple, especially when we haven't had much experience in the professional world. It was very informative to redesign this building and learn from our mistakes initially with help from faculty. So
awesome. Great to hear about your project. Thank you so much. And we'll head to our next group.
Hello, we're here with our industrial engineers who have worked very hard this past year for their project. So tell me about yourself and your project.
Hi, I'm Renata.
I'm Sophia.
And I'm Nicole. Okay, so for our project, we're working with Mediclick. This is a telemedicine provider in Latin America. And currently their issue that they face is that their doctors are freelancers. So during high demand periods, they do not have enough doctors to cover all patients.
So in order to address this issue, we created a Python tool code that basically will take into account 3 different pillars. First, a doctor classification, then a coverage aid gap, and then it will generate a dynamic incentive planning in order to fulfill that unmet demand.
With the code, there's different things that Mediclick will be benefiting from, starting with reducing the amount of time that the company is using to be able to produce this scheduling by half. Then we're increasing the amount of doctors that are participating, and the missing ones are reducing by 75%. Adding doctors means that there's going to be less abandonments, and that's going to eventually increase the amount of revenue the company is doing with the model. And we will be expecting that for the entire year, they're making 36,000 more. And think about that. This is a Chilean company, and it's all based in Latin America. So it's a big impact for them. Thank you.
I love the extreme detail that you guys have on this table. And if you guys were to pitch this starting off, who would you start pitching it off to and in which region?
Well, technically, this is already pitched up to a specific company because we work with them, and we signed an NDA, so we don't know how's the structure for that to be able to implement it to different companies. But this is applicable to anybody that is struggling with their scheduling.
Well, I can tell that you guys definitely did your research very well put together. Thank you so much for your time. We'll be moving on to our next group with Braden.
All right, we're here with our next group. Could you go ahead and introduce yourselves?
Hi, I'm Alexandra.
I'm Lou.
Isabella.
I'm John.
And can you tell us a little bit about your project?
Of course. So this is Easy Align, a remote positioning system for wind tunnel applications. So in wind tunnel testing, smoke visualization is really important to visualize the flow around physical models like airfoils or buildings. But to position the smoke emitter, there is no standard way to move it. So what we built is a remote positioning system that will move the airfoil with the touch of a joystick. So today here we have a miniature model of our system. So this is a 2-axis system that will move our laser pointer today, but our actual system is a full 6 foot by 6 foot product that moves essentially like this, and you can move the smoke stream from a desk or anywhere you want to be, and you don't have to physically enter the tunnel to move the smoke stream.
Awesome, great, thank you. And what was your favorite part about this project?
Working with my senior design group. We had an amazing group. We work really well together. We've been friends for forever, and I just had a great time working with them. We're all really great workers.
Awesome, thank you so much. Your project was amazing, and I look forward to seeing what you all do in the future.
Thank you.
And we'll head to our next group with Priscilla.
Hello, welcome to our next group. And can I get your name?
My name is Chloe Soriano.
Andres Leon.
Hi, I'm Amita. And tell me a little bit about your project. Oh, sorry.
And I'm Ian Lee. Nice to meet you all.
And tell me about your project today.
So we're Team Isomotion. We're a biomedical startup that started out of our senior design project here at the University of Miami. So we're biomedical engineering, and so what we want to do is standardize a certain PT practice called instrument-assisted soft tissue mobilization. And so what that does is that it increases blood flow and stimulates healing. And so the focus of this is that currently only licensed PTs can do it. And it's not as accessible. And because it's a PT practice, it is not standardized. So what we did was we mechanized it. And then we have like a pressure sensor that goes along with it so that the PT can get real-time feedback on how the device is actually working for the patient. This helps to increase patient compliance in the moment. And so the goals for future testing is that we already verified this with 50 PT clinics. We've received over $12,000 in funds thanks to the USTAR Accelerator program here at the university, as well as the EPIC competition. So we are in 2 different pitch competitions. And so in the future, we hope to receive more funding and have this as a medical device startup.
This is wonderful, very applicable, and I'm very glad that the school could help you start it up and that you could see real results. I mean, that is the point of our Senior Design Expo. Thank you so much, guys. Wonderful team. We'll be moving on now to Braden.
All right, and here we are with our next group. Hi, guys. How are you?
We're great.
Awesome. And can you tell me what your names are and a little bit about your project?
So my name's Raphael.
My name's Brian.
I'm Aaron.
Essentially what our product is that it is a at-home rehab feedback. And so essentially what it does is that it is able to tailor and program a patient's rehabilitation experience. So right now, about 2 million people in the US alone suffer from partial rotator cuff tears. And about 50 to 70% of those fail to adhere correctly to their specific program. So with our app, it is fully functional in an app and in a cloud database that the PT and the patient can both view. And what it does is it essentially can track a patient's motion very precisely. What that does is that it reduces rehabilitation anxiety for doing exercises wrong, and it can give the PT a wide range of data to basically view how the patient is doing, how the muscle is recovering, how fast they're going, if they're adhering correctly. And as the PT can view that, they can continue to tailor and customize a patient's experience so that they can recover properly and adhere correctly to their program.
Awesome. As being somebody who has had 2 shoulder surgeries in the last 3 years, I really enjoy this project, and you guys did great, and thank you so much.
Thank you.
And we'll head over to our next group with Priscilla.
All right, thank you, Braden. And here we are with our next group. If I could just get a name.
Samuel Nunez.
Ian.
And can you tell me about your project today?
So our project is a module synthesizer. Basically, if you've seen a recording studio, it is like very bulky, very complex, and very expensive. So what we did, we downsized it. We made it portable and affordable as well. And it produces sounds with these chips. So and each chip produces like a tone or a beat.
We can play this sound for you here. I don't know if we want to put the microphone because it'll play out of these speakers. So should be playing a sound here now, and we can adjust it as we want with these knobs. And each of these modules will play a different sound.
That's very impressive. I love that you guys have a variety of different sounds for testing, and the model looks very nice. Thank you so much. We'll be moving on to our next group now with Braden.
And here we are with our next group. Hi, guys. Can you introduce yourselves?
Sure. My name is Franco. I'm Ethan.
I'm Maya.
And can you tell us a little bit about your project?
So our project is a universal heads-up display unit for car navigation. So our goal is to help reduce distractions while driving by being able to project your directions directly onto your windshield.
It's typically a product only available in luxury vehicles as well. So we wanted to make a component that you could just mount on your car and that anyone could use. So when you first boot it up, this is the screen that pops up here. And then he'll show the demo. No. But yeah, you can enter any destination and it'll automatically pop up and it'll take you to this screen to confirm your destination. And then if you press OK, it'll show you the ETA and then text-based directions as well as navigational cues directly on your windshield.
Awesome. I love how this project really addresses a safety issue when driving. You guys did great, and thank you so much for your time. All right, and we'll head to our next group with Priscilla.
All right, welcome to our next group. Can I get everyone's name, please?
Gabriel.
Jose.
Evan.
Santiago.
My name is Tom.
Perfect. And tell me, Tom, tell me about your project. What did you guys work on?
Okay, so we redesigned the engineering systems for a 6-story office building in Omaha, Nebraska. We were actually approached by Carson Wealth Group, which is a financial consulting firm, to do this retrofit. And so they wanted to redesign these systems in the mind of energy optimization and sustainability. So keeping those in mind, we designed various systems that go from civil, structural, MEP systems. And on our poster here, you can see some of our major components. So we have a dynamic shading system that wraps around the building that reduces sensible heat gain and the load on the HVAC system. We have a rainwater catchment system that filters rainwater and supplies it to toilets and urinals, which is a major component of the plumbing load. We also have structural engineering. We redesigned the entire structural system so that it's sustainable. And we have a 6-story staircase that suits all 6 floors and promotes well and lead values. So we got a lot from this and we learned a lot.
Sounds very interesting. I see that everyone's coordinated. I can tell everyone's pretty good with teamwork.
Like our goatees.
Oh, even down to the detail. So tell me, what was the best part about working together as a team, and what was, I guess you could say, the most efficient way you guys were collaborating together?
I think just our overall team bonding was really nice and helpful. The way we worked, which is not how everybody works, is we all got together in person. So we would all meet up in the school library and get on our computers and actually look face to face. So if we ever had a problem, we could just tap on the person next to us and say, "¿Qué pasa?" And they keep going. So
That's very helpful, and they have said that working together in person is more effective. So I'm glad you guys worked together. This is an amazing project. And let's go hear what our next group has to say.
Here we are with our next group. Real quick, can you go ahead and introduce yourselves?
Hi, so we are Inspire Therapeutics. I'm Isabella.
I'm Adair.
I'm Sophia.
And can you just tell us a little bit about your project?
Yeah, so basically our product is addressing diabetic foot ulcers. So it is the next generation wound healing treatment, and it is an injectable hydrogel treatment that's able to heal wounds from the inside out. It's able to bring blood flow back to the wounds, which is the root cause of these diabetic foot ulcers, and it's able to cause rapid wound closure and rapid healing of these wounds at a short time frame, which decreases complications like infections and amputations and leads to overall a better healing quality for these diabetic patients.
Great. And just one follow-up question. Were there any challenges that you faced while doing this project?
Yeah. So definitely, we definitely had to optimize this product a lot. Once we got our final trial, we were actually able to move into animal studies. And moving into animal studies after just a few months is really challenging. We had a logical surgical methodology optimizing, but overall, we're really happy with the results we got, and we can't wait to take it further.
Great. I love your all's project. Thank you so much for your time. Thank you. And we'll head over to our next group with Priscilla.
All right, welcome to our next group. And if we could just cut in really quick for an interview. Sorry, if we could just cut in for the interview. Come on in. So give me your name and tell me a little bit about your project.
Hi, so I'm Landon Brody. We are optimizing the Miami academic transfer evaluation system for student success. So basically, we're taking the current MATES process and optimizing it so students have a better way to actually complete their transfer equivalencies. Right now, there's a lot of problems with communication between different departments, including course evaluators, admission, and registrar. So cleaning up that communication is key, as well as improving the functionality overall on the back end of the system.
Definitely. And when in terms of creating your prototype, what would you change from Mates to your new prototype idea now?
So mainly what we wanted to do was we built 3 Figma mock-ups of the new system. And what we want to do is give students more information as they go through the process, so they're less confused and they're more likely to get successful transfer requests as they go through.
Definitely. I think a lot of students will benefit from this. I remember having to run around department from department. So I'm glad that you took an issue and definitely found a solution for future generations at UMiami. Thank you so much for your time. And let's hear it from our next group.
Here we are with our next group. Hi, gentlemen. Could you go ahead and introduce yourselves?
Hello, my name is Ben with the Mount Sinai Re-Registration Group.
I'm George.
And I'm Logan.
And could you just tell us a little bit about your project?
Yeah, so early on, Mount Sinai is looking to relocate all of its cancer operations into this new facility. This new facility will be opening early in 2026. So our task was to create a badging and re-registration process that they can implement into this new facility.
Yeah, so some of the key deliverables that Mount Sinai told us they wanted us to accomplish was to enhance patient satisfaction while maintaining low labor costs and also improving security.
Yeah, so essentially we came up with 4 different models, changing things like the part of the process when patients are getting banded, how much help there is with registration and filling out paperwork, and then basically compared these models in different staffing allocations using simulation software. And we came up with multiple viable solutions. The one that prioritizes patient satisfaction, making sure there's help throughout the process, and then a second one that limits labor costs while somewhat sacrificing those other project success criteria. Thank you.
Great. I love seeing all these projects that are tackling issues amongst actual companies. So it's great seeing that you guys actually worked with a company to make this happen. So thank you so much for your time. We'll head to our next group with Priscilla.
Welcome to our next group. And here we have these wonderful ladies. Can I get everyone's name?
Hi, I'm Sophie.
Hi, I'm Cheyenne.
I'm Rachel.
And I'm Ragad.
And I see you guys have a mannequin and a very interesting prototype. Please tell me about your project today.
All right, so we are Vasopass. We are a first of its kind active cooling wearable that essentially detects the hot flash with a high temperature sensor, and it triggers this cooling mechanism.
And tell me, what guys inspired you to do this? I know all of us sometimes get hot in our clothes, but what really drove you to make this your main project?
So one of our team members, her mom actually goes through menopause, and so she was telling us about different symptoms that she goes through with hot flashes, and we knew that we wanted to target this with our project.
And have you guys been in any communication with the Miller School of Medicine, collaborated with anybody else outside of the organization?
We have medical students that we discuss the current treatments, and also physicians, gynecologists, oncogynecologists, who treat patients who are undergoing hormonal therapies and also trying to treat their hot flashes.
All right, that sounds wonderful. And one last question for you would be, what was the best part about working with your team this semester?
Honestly, we really worked well together in collaborating with these crazy ideas. I don't know how we settled on one, but I'm really excited for the future of this project and for the future of us working together.
Definitely. It's always better to have more ideas than less. Am I right? Thank you guys so much. Let's go check out what our other group has to offer.
Guys, I hate to interrupt. Hi, could you just introduce yourself real quick?
Hi, my name is Ronnie.
And can you tell us a little bit about your project?
Yeah, so my project is a contactless recognition and vitals monitoring application for primary care clinics to kind of streamline the time you spend waiting to document and get verified as a patient, and also save the time waiting for your physician assistant, getting your vitals checked. It streamlines that into one comprehensive platform.
Great. And did you have a demonstration or something to show us with your project?
I'll show you guys part of the video right here, but you could see this is in partnership with the technology from Neurologics, but it uses this thing called transdermal optical imaging to detect color changes in your face that the naked eye can't see, passes that back to their algorithm, and then it's able to create a holistic vitals report that's very transparent to the patient about what's healthy, what's unhealthy, and that's sent directly to the doctor when they go into their queue and can look over their doctor's notes.
Awesome. This was a great project. Thank you so much for your time. All right, and we'll head over to our next group with Priscilla.
Welcome. All right, and we have our next team here. Could I get everybody's name?
Hi, I'm Ella Schwartz. Hi, I'm Haley Stamberger.
Hi, I'm Maddie Bloffis.
Hi, I'm Ramsey Shahada.
Hello, my name is Sarah Paschke.
Perfect. And can you tell me a little bit about your project today?
Yes, of course. So we are Elemental Engineering. We are a firm that specializes in structural, civil, mechanical, electrical, and plumbing engineering. And we were tasked with a complete redesign of a 6-story office building in Omaha, Nebraska as part of the Architectural Engineering Institute competition. We were tasked with reducing energy usage by over 50% on our site, designing a multi-story celebratory staircase and atrium, and coming up with an innovative facade and envelope design. We accomplished this with a 6-story spiral staircase, a 56% energy reduction through sustainability measures, and a reactive facade that moves with the sunlight to help prevent overheating and overcooling of the building.
This sounds wonderful. I'm so happy for you guys. I could tell the dedication was there. I've seen them this semester work throughout it. And tell me, what was the best part about working together in a team?
I think it's what we learned. We really, really worked hard. We produced more than 1,900 pages of calculations, and we truly learned how to be an engineer through this process. We genuinely believe our building is ready to go. It's going to pass permitting and pass the codes, and we're able to take these skills into our master's degrees, into the job force, into internships, and help get promotions sooner on because we know what we're doing already.
Well, ladies and men, this is very impressive. I'm so happy for you guys, and I hope it becomes applicable in the future. Let's move it on to Braden and see what he has.
All right, and we are here with our next group. If you could just real quick introduce yourselves and tell us a little bit about your project.
My name's Baron. I'm Sebastian. I'm Trevor Urio. So I'll speak a little bit about our project. This is called the Kicking Coach, and it's an indoor field goal kicking simulator. So the system works by running on a Raspberry Pi. It calculates the velocity based on images that are taken from the camera, and then turns them to our software simulation where it can simulate how the kick would have varied based on different distances, different winds, and gives the kicker feedback instantly.
Awesome. What a great project. Thank you so much for your time. And we'll head over to our next group with Priscilla.
All right, and here we are with our next group. And can you please tell me your name and tell me a little bit about your project?
Sure. I'm Luis Cortez. I'm joined by Pam and Adam. And what we did is we did an industry partnership with Sterling Foods, a meat packing facility, and we digitized and automated all their real-time data capture and production analytics.
Perfect. And I see you guys have a model here. What would you guys be using this for in your project?
So all this equipment would actually go on a manufacturing floor at a factory. Essentially, what would happen is this equipment would be utilized in the day-to-day production away and essentially get boxes of meat, and then we'd be able to calculate loss and cost from this.
All right, and what was the feedback from the company that you guys worked with, or have you reached out to any?
They loved it. They actually want us to finish out the implementation. They want us to implement it at another company that they have, and there's actually been some, I guess, talks of a third company actually reaching out and saying, hey, we really want your product. Yeah.
Well, that's very impressive, and especially considering you guys are about to graduate. I hope this leads to new opportunities, career offers, and I'm very happy for you guys. Thank you. Of course. We'll be moving on to our next group now.
We're here with our next group. I hate the interrupt, guys. We're here with the live broadcast, so sorry about that. Real quick, could you go ahead and introduce yourselves?
I'm Noah.
Hi, I'm RJ.
I'm Morgan.
And I'm Dante.
And whoever wants to answer, could you just tell us a little bit about your project?
So for Hypersense, we are looking at a way to detect hyperventilation with children that have absence epilepsy. So for children with absence epilepsy, over 95% of cases, hyperventilation is their main precursor. So we want to design a screen printed shirt with a conductive ink that measures your respiratory rate to help detect the mark before you hit hyperventilation. So our live model here could show as he's breathing out, and then on our live feedback here, as you're breathing in and out. Once you cross that threshold, it gives a feedback with a buzzer and provides the warning to say slow down, settle down, and relax. So we did that with our conductive ink, thanks to Novocentrics. It's a conductive ink company that helped give us the ink. And with that, we hope to make an app with it that can provide feedback to the caretaker, the patient, and the user itself. And the goal is to eventually expand that onto you go to military, firefighters, and whatever you can name that uses respiratory rate.
Awesome. I love how there's so many applications that this could go towards, and thank you so much for your time. And we'll head over to our next group.
Here we are with our next group, and can I get your name? Allie.
I'm Deshaun.
And tell me what your project is about here today.
So our project is about improving the stormwater the water quality within the Little River Canal, which is a canal further up in Hialeah. And what we're proposing is doing infrastructural improvements such as bioretention cells, permeable sidewalk pavements, and exfiltration trenches, so that we can, instead of having the stormwater being diverted to the canal, we can have it down into the groundwater.
Perfect. That sounds very interesting. And let me ask our other half of the group, what inspired you guys today to do this project and this idea?
Well, we kind of got we had this like idea of looking at the Little River Canal, but it was we had to look at it and see what was like impaired about it. So we found that bacteria, fecal indicator bacteria, was the impairment. So we specifically looked at that along with nutrients, and also there was a low DO level. So we decided to implement different green infrastructure, and so specifically we did use the exfiltration trenches, bioretention cells, then aeration systems, and also permeable pavements to replace the sidewalks. But yeah, just because there was such high fib levels in the Little River Canal, that's why we kind of want to focus on that and try to help reduce overall.
Definitely. I think that's a very important factor that we have to take into consideration. And I didn't get everybody's name here. Can I get your name? Bella Chow.
Mackenzie Howell. Sarah Murphy.
All right. And that is your team 12. We will now be moving on to our next team and finding out about their ideas.
We're here with our next group. Real quick, could you just go ahead and introduce yourselves?
All right, so my name is Jose Cardenas.
I'm Daniel Muscat.
I'm David Rodriguez.
Joseph Fernandez.
We're introducing Resonant. Basically, the idea for this project just came from dissatisfaction from current music recommendation systems. Basically, the way they do it, the way they recommend a song to you is by using metadata tags that are attached to the song instead of using the actual sound of the music. Basically, what this does is that it skips a lot of the nuance that comes for each song, and it could potentially just basically skip like hidden gems that you might be able to find otherwise. So what we made is we take each song and we convert it into a spectrogram, which essentially gets its fingerprint, and then we compare that with every other song that we have in our database using machine learning, and then it'll return the top 10 songs that are most similar in terms of only acoustics. Basically decoupling everything else that platforms like Spotify and Apple Music use to recommend songs. And we find that this is a better way to discover music.
Awesome. What a great project, guys. Thank you so much for your time. And we'll go ahead and head to our next group.
All right. And here we are with our next group. Could I have everyone turn around? A little group photo. All right. And let me get everybody's name really quick. What's your name?
Michael? Dennis.
Jocelyn Kushti.
I'm Kellen. I'm Kevin Marquin.
And in terms of your project, tell me, who are you planning to help with this project? What was this product designed for?
So this project was designed to help anyone and everyone in any field, right? So what we did is we emulated a quantum computer, which what it does is it takes computations, extremely tough computations, and runs them in parallel, making everything faster, getting to the result even faster, right? So it can be applied to anything. But the main problem is right now, quantum computers are not accessible, needs to be working in freezing temperatures, extremely big and extremely expensive. So what we did is we made it work. If you look behind you right there, we made it work on normal hardware, right? Which is cost less than $5,000. So the price is done. It's working right now in room temperature. So we don't need to be in freezing temperatures, right? And then it does the computation. It emulates it exactly the same. And it's also small in size. So it's not sitting in one place. You can take it and use it wherever. So any industry, any organization that wants to buy it, we can get it, set it up for them, and then they can test their algorithms in order to make everything faster and get their results faster.
Definitely. This will sound very appealing to many different companies. This was a great project, and thank you guys for your time. We'll be hearing next from Braden.
Here with our next group, could you go ahead and introduce yourselves?
Hi, my name is Tian Fan.
I'm Ansgar.
I'm Alyssa.
And tell us a little bit about your project.
So I've worked in a cell engineering laboratory since my freshman year at this university. And so one of the most tedious parts of cell engineering is counting cells. So we wanted a way that was low cost to automate that process. And so we made an application that uses a neural network that we trained that identifies cells in an image from a hemocytometer and gives you the count based off of that image. And this is a low-cost option that integrates into any microscope. It takes the place of an automatic cell counter that costs upwards of $3,000 to $10,000, and it can give you an accurate cell count based off of a simple photo. So with a $100 microscope camera and our application, you can click one button and it will give you the cell count.
Great. I love how simple this solution was. You guys have a great project, and thank you so much for your time.
All right, welcome back. We're with our new group of industrial engineers. Can I get a name?
I'm Caden Steeman.
I'm Benny Guerra. I'm Sabrina Chandra.
And this has been a very dedicated team throughout the semester. So tell me what your project has been about and who you want to impact.
So we partnered with a tax and accounting firm called H&Co. It's located here in Miracle Mile. And essentially what we did was we
I'm sorry, sir. We're on a live stream. You can come back right after.
we fully revamped the onboarding process, which is currently a manual process, which takes 3 to 4 days. And with our new automation bot, it'll take only 2 to 3 minutes. So essentially what we're doing is we are automatically assigning the client to a team, as well as identifying what type of client we're dealing with. And so the impact over 5 years, what we've determined is we are, instead of spending 2,500 days in this onboarding process, we're now spending only 12.2 days because our new process only takes about 5 or 6 minutes, right? So we projected that we're saving about $3.2 million for the firm over the next 5 years. And yeah, that's our project. Thank you.
It's very great to see the drastic difference in your results. That's definitely an optimal solution, as we say with industrial engineers. Everything's very on brand, and this is a great project. Thank you, guys. We'll be turning it over now to Braden.
Our next group, another ITD student. Could you quickly introduce yourself and tell us about your project?
Hi, so my name is Grant Martin, and this is basically my ITD capstone project. So in essence, if you are a restaurant that is struggling to make money or struggling to retain your customers, you can come to me and use my system Loop to basically gather data to understand what you're doing wrong. And just like going through a little bit of detail, you would tell me like your biggest problems, pain points, and what your goal for your restaurant is. And then using my like AI system, I will analyze your feedback and then create a custom survey for you to give your diners. And then the diners will answer the survey, give me data, and then my system will visually represent the data and analyze it using AI to tell the restaurant what they're doing wrong and what they could improve.
Awesome. I love the project, and thank you so much for your time. And we'll head over to our next group with Priscilla.
Welcome back. We're here with our next group. Can I get everybody's name?
Nicole, Amari,
Devin.
Jada. And with this project, we can see a very complicated design and very innovative. So tell me, what must have been the biggest challenge throughout the past year when developing this product?
Our biggest challenge was essentially finding the right need to fill. And then essentially we had to look around everywhere. There were so many different things telling us there's a need here, there's a need here. But essentially what we did was listen to the medical campus and see what they are having problems with. And sometimes it's as simple as that. Sometimes a simple problem being filled can have a big impact.
I really like that you guys talk to the medicine school, especially because that's so big down here in Miami. I love the collaboration. You could definitely tell you guys worked very hard. Thank you so much for your time. We'll be hearing from our next group next.
Our next group, hi guys, could you quickly go ahead and introduce yourselves? Excuse me, sir, we're doing the live broadcast.
My name is Jason. Hi, I'm Oscar.
I'm Danny.
Hi, I'm Timothy.
And can one of you tell us a little bit about your project? I'll come over here to you.
So we built a fixed wing vertical takeoff capability search and rescue drone. basically there's a lot of people that go unaccounted for when there's natural disasters such as flooding and hurricanes. So we created a drone that can not only take off from anywhere, but can fly for about 5 hours. And ultimately we did this because with thermal sensing, LiDAR, and GPS, we can find people by simply just putting this drone in the air, and it can help finding these victims, getting them the help they need.
Awesome. I love how this combats an issue that we face right here in South Florida. So thank you so much for doing this, and thank you for your time. Thank you. And we'll head to our next group with Priscilla.
All right. Sorry, guys. Thank you. We're here with our next presentee. Can I get a name?
My name is Somi Izyashi.
And I see you have a lot of details here. So tell me, in terms of your project, what was the most interesting fact and unique fact about the solution and the potential outcome?
Our product is completely 100% biodegradable and can return to Earth in 5 days as a temporary structure. So it can actually replace tents and other temporary structures that cause a lot of, waste and CO2.
And can I get your name and what was your favorite part about working together in a team?
My name's Christian Guerrero, and favorite part about working on a team with this guy, we play basketball during our free time and downtime, and then hop right back in.
That definitely helped you guys work better and bond and work as a team. Yeah, definitely. All right, and let's find out what our next group has to offer. Thank you, guys.
I'm sorry, everybody. I'm going to have to interrupt real quick. We have the live broadcast. Sorry. Hi, guys. Could I just have you introduce yourselves real quick?
I'm Eva.
Hi, I'm Rob.
And I'm Emma.
And if one of you could you please explain me what your project is?
So our project is Lead Vision, and we created a system to address ECG misplacement, which leads to misdiagnosis in the patient. And so we figured the best way to address this issue is by addressing the nursing students specifically. These are the people who are learning how to actually place these ECGs onto a patient. Right now, the only way that they're learning how to do this is by using this map here, and that's not enough. 1 in 20 patients are actually misdiagnosed because of the misplacement of ECG leads. So we decided to actually create a projection mapping system to be able to create a more interactive hands-on approach to be able to teach these nursing students how to place the ECG leads. So that's kind of what we did.
Awesome. Thank you so much. This project's great. And thank you for your time. All right. So I think we are about wrapped up there. Priscilla,
definitely.
what did you think about all the projects?
I think I learned a lot, and I can't wait for my turn next year. Did you learn a lot, Brayden?
I did. And I would have to say there's a lot that really caught my eye. For example, the prosthetic eye one.
Me
No pun
too.
intended. That one was
Which,
great.
by the way, you guys can vote on the WOVA app and just make sure to put in the team number. But I definitely thought that was great. It was really cool to see that everybody incorporated companies, reached out to real organizations, and now some of them might even get potential job offers. So it really highlights the importance of this expo.
Yeah, and overall, this was a great experience. And I want to say thank you to all the seniors who presented today. Thank you for everybody who showed up, everybody at home who is viewing online through this live stream. And thank you to the faculty who also helped make all this happen. And remember to go on Instagram and LinkedIn and follow us at UMiami Engineering. Follow us on both of those. And we'll be back at 7 o'clock for the live award ceremony. So
Make sure to tune in.
And thank you all for coming, and we'll see you again at 7.
Thank you, guys. Bye.
Hello. Hello, everyone. Thank you. Thank you for joining us today, and thank you for coming to the expo. We are almost ready to start our awards ceremony. So I have a few words for you. So first, for the graduating seniors, I know about a third of the class probably has been in my classes. So congratulations. I love seeing you here the day of the expo. I want you to do something today. So seniors, listen to me. I want you to turn around and see your friends and thank your friends. I want you to think of where you were 4 years ago in August of 2021. How much you've grown, how you are a better person now because you came to the U, because you talked to people who were different from you, because you talked to people who came from other places. So please thank that person you were 4 years ago. Thank your friends, and don't forget to thank your parents. I know there's any parents here today? Raise your hands. Thank you, mom and dad. Any grandparents? Any grandparents? Thank you, grandpa and grandma. Thank you for being here. Thank you for supporting your children and for trusting us. This is a very special day. I am the mother of 3 boys myself, not in college yet, so I know how much work you put in for 18 years, so you deserve to celebrate this 4 years later as well. So we are almost ready to start. We're going to give our awards, so please, thank you for your patience, and I'll be out in a couple of minutes. Thanks.
Eileen, can you come to the front, please? Good evening. So we're setting up the thumb drive with the final presentation right now. I'm Dr. Maville, and I wanted to thank each and every one of you for coming. And most especially, I wanted to thank the seniors. They had to put up with tons of emails all week and last week from me, and you guys all shined tonight. Congratulations, you did a great job. So if anybody's looking to hire, I'm sure there's many very qualified engineers in this room tonight that will be looking for jobs. So welcome to the Expo, and Dean Biswas, can you please come to the stage?
Hey. Yeah, seniors, congratulations again. This was just fascinating. It's every year it goes up a notch. So thank you all for putting on such a great show, right? And parents, well-wishers, we also have a lot of visitors here. So thank you all for coming. And it's been a great pleasure. I would like to congratulate once again the class of 2025. Let's give them a big hand. And some of our special sponsors, Schoenfield, and also others, the College of Engineering, the Alumni Association. You'll hear from them as the evening goes along. At this time, I would also like to acknowledge all the faculty judges, the Expo committee. They did a fabulous job. So thank you, and let's give them a big hand. And we also have very special industry judges. So it gives a lot of relevance to judging also. So thank you again, all industry participants, for helping us judge. Thank you. At this time, I would like to invite our provost, Willie Prado. He's here, and I'll of course speak for him. I think he was equally impressed by watching all the presentations. Yeah, Willie. And Willie, please make a few remarks.
Thank you, Dean. Good evening, everybody. All right, that's not bad, folks. So I want to thank the Dean. I want to thank all of you for being here. What a great event this is, isn't it? It's amazing. Congratulations to all the seniors. Congratulations to all the faculty mentors. It really does take a village. And as I was going around and looking at all the different presentations, honestly, I don't know what the parents think and some of us who are a little bit older, but we have a lot of hope for our future. There is innovation happening. There is pushing boundaries. There's patents already. I mean, it really is absolutely spectacular. What you all do, seniors, and what the faculty mentors do every single day, it really is impressive to be here. I'm going to stop in just a minute. I do want to also, I did see Jennifer Kaplan earlier from Schoenfeld. She's right there. Thank you so much once again for sponsoring the event. Thank you. And again, just a special congratulations once again to all of you. Thank you all. We look forward to seeing what you all do next. Irrespective of the results, you are all winners. And I know there's a couple of you that are participating in the U-Star competition tomorrow for the 100,000. Good luck to you as well. Yes. Bring it home, engineering.
Okay, thank you, Willie. That was great. And thank you for coming every year, year to year. And we look forward to seeing you next year too. It's a great pleasure to now invite a fellow chemical engineer, Jennifer Kaplan, to make a few remarks.
Thank you, Dean. Thank you, Willie. Well, yes, as a fellow engineer, I'm glad I'm not competing with these engineers because I would not get a job. You are all incredibly impressive. And on behalf of Schoenfeld, we're really honored to be able to sponsor this event again this year and see the unbelievable work. As I said, I don't want to compete with any of you for jobs. We're so happy to sponsor and to congratulate all of the seniors. We know you're going to go on to do some amazing, amazing things. Thank all the faculty. I was honored to judge the pitch competition this morning, and I was blown away. So congratulations to all of you. Thank you, Dean. We're glad to be here.
Thank you, Jennifer. And congratulations. Congratulations to everyone. I think Willie Prado put it well. Everyone is a winner. So, of course, a few will be called up, but every single one is a winner today. The morning pitch competition was excellent. This is just fabulous. Let me now turn over to Dr. Nina Miville, and we should give her a very special hand for putting this entire thing together. So.
Well, I have to thank my committee. We all worked together for this. So this year, we had 2 engineering students. They designed our graduation medal, but in addition, they designed a special medal that goes along with the graduation medal as the Expo medal. So tonight, the winners will go home with their Expo medals. Don't lose them because you don't get another one on graduation day. So I wanted to acknowledge Nicole De Abreu and Ben Broyles for working hard. We're really proud of the medal that they designed collaboratively, which is another example. So I want to bring forward Dr. Lippman for the first presentation.
Thank you. So I have the honor of presenting for the Biomedical Engineering Department. So for the outstanding biomedical engineering project for this year, we have Katayan. Congratulations. Come on up. So we also wanted to recognize another team, Sinew Stride. This is a very special team. They actually have been working on their project for actually more than 2 years at this point. They've won multiple awards, including the ACC Inventor Prize. So we'd like to honor them one last time. Come on up. We're going to remember up on the line, up on the line.
Thank you.
Dr. Gang will be presenting the award for civil and architectural engineering. And as you can tell, we want you to come up these stairs so you can get your medal.
This is my honor to present the best project for civil architecture engineering department. So the award goes to elemental engineering.刀席。
And their project mentor, Dr. Trussoni. She's here? No? Okay, then you. He's right there. He's right there. All right. You're next. So now we'll have the Department of Chemical Environmental Materials Engineering, Dr.
Thank you so much, Anina. Again, it's a great pleasure to kind of an honor to present the best project for chemical, environmental, and materials engineering. So can the team come up, David as well, and CY. I don't see CY. David? Yeah. Take a picture as well.
Where's CY? Okay. Congratulations. Take center stage, sir. Congratulations once again. And now for the Department of Electrical and Computer Engineering, Dr. Asaf Jalani.
All right, it will be my honor to present the winners of the Electrical and Computer Engineering Department Best Project. And it is quantum computing. Come on the stage.
Sakura, can you please come to the stage for the picture? Thank you. So the next award is for the Department of Industrial and Systems Engineering. Why isn't this working? There it is. And the winner is Mediclick. Ladies, you're moving very slow. So next, I would like to bring Professor Lokesh Ramamurthy for the Innovation, Technology, and Design. This is the first year that we're graduating a class in that new program, and he's here.
All right. Good evening, everybody. The best project for innovation, technology, and design goes to Local Lens. I would like to invite Dr. Dwerk and Devika, Professor Devika, to join me on the stage. Local Lens team, Catherine and Anna. Where are they? All right, this way.
So now for the Department of Mechanical and Aerospace Engineering is Dr. Vassallo.
Hello, everyone. So for the last of our department awards, we're going to present the best project for mechanical and best project for aerospace. So we're going to start with our best project for mechanical. It's the dental implant design and development. Go the other way, the other way. Because you have your medals. Cross, you can cross. Yep. And then Dr. Yang for the picture. Yep. And now for our last department award for the best aerospace engineering project goes for the JDOD drone. Okay. So now, this is what you've been waiting for. We're going to start with the awards that were Expo-related awards. So these are the awards that were decided today. Okay, and we're going to start with the Best Expo Display Award. And that goes to Caution. So, back on the stage. You want to be in that? You should be in that picture, the biomedical. No more medals. No. Just one medal.
Yeah, I was like, I don't know.
I'm so excited. Well deserved. Nice. What's the next one? Okay. Okay, second of our Expo awards. Now the award for the best poster goes to Gearling's Facility Design. Guys. Nope. Wait, that way. So you can get your medals. Yeah. Have we been given this? Now, one thing that I don't think anybody has mentioned, so for those of you here today and all the juniors and sophomores, every one of these awards comes with a check. Not a real check, but there's a monetary award with this. So Now, the Best Expo Video Award. I'm super excited to give this to Wayne.
No. So I want to bring forward the president of the College of Engineering Alumni Association, Daniela Martinez. Daniela was one of my students many moons ago, not that many moons ago. And I'm really proud that she's now leading the College of Engineering Alumni Association. And cheers to present the People's Choice Awards. Yeah, go ahead.
Hello, everybody. So I would like to just quickly introduce myself. As Dr. Maville mentioned, my name is Daniela Martinez, and I am the president of the College of Engineering Alumni Association. The association, I like to take pride in the fact that we are only 2 schools in the whole university that have an alumni association. Everything else is strictly related to, the different communities. So whether you live in Miami, in Chicago, in New York, etc. So because of this reason, I do encourage you all to take advantage of that. The Alumni Association is composed of any alumni who want to attend our event, near or far. You do not have to live within the Miami, Broward area. And then it is composed of 20 board members. They are exceptional people. We look at applications every year, and I have met incredible professionals. Some of them are in the crowd, so I definitely encourage you all to introduce yourself. We will be at the event later today in the terrace. So please, after this, make your way over to the Moss Terrace right outside. And then 7 executive board members. So these board members are who work alongside me to make sure that we do these events, that we stay connected. And like I mentioned, they are business owners, they are VPs, they are CEOs, they are people who have done tremendous things with their careers after graduating. So that is my spiel on the Alumni Association. But let me present this award. So we did sponsor these awards. So for the 3rd place of the People's Choice Award goes to Care Access Optimization. Bueno. All right, now help me congratulate the 2nd place People's Choice Award winner, Broadband Inventory Optimization.
Pays off.
All right. The last award that we'll be presenting is the first place for the People's Choice Award, and that goes to Wave.
Thank you, Daniela. So now I'd like to bring Lokesh and Dr. Sam Amin. They are going to announce the pitch competition.
Hi, everybody. This is the winners of the Epic 2025 award. It's a cash prize. First place goes to $30,000. Second place, $20,000. Third place, $10,000. The third place goes to I Ask Motion team. Chloe, Amina. Congratulations, guys. Congratulations, guys. You did. All right. We'll do a picture. Come in the front. We'll do a picture. Thank you. The second place goes to Therapy AI. Therapy AI team. All right. Congrats. I like freaked out. Oh my God. In the first place, much wider $30,000 prize goes to Bonsai.
Thank you. Thank you so much.
All right. All right. All right. Congratulations. All right, guys. Picture. Quick picture, guys. All right. Thank you all.
So these next two awards are the awards that were judged live here by 12 different judges. So the first award is for the industry impact.
Okay, good. The Industry Impact Award goes to Caution. Good. Four. Congrats. You have to say anything?
So this next award is for the best overall College of Engineering award. This is judged by 6 faculty judges. This is based on technical merit in addition to innovation, etc. So this is the best award of the night.
So the grand prize goes to, in honor of Dr. Asfor, the best senior design project goes to Inspire Therapeutics.
So this concludes the award ceremony and the expo. I do want to thank all of the College of Engineering staff who helped set up throughout the day and worked tirelessly tonight, and they get to do cleanup tonight. And I want to remind all the seniors that you have a welcome to the club event. It's on the Shalala Moss Terrace following this ceremony. And the Alumni Association has gifts for all of you. So thank you once again, and we will be here again next year.